Hello again, welcome to another lesson in geometry. Today we are covering section 10-1, areas of parallelograms and triangles. All right, so we have vocabulary here, some review. So the diagram below shows the different types of parallelograms. So remember a parallelogram is a quadrilateral, so it has four sides, where the opposite sides are parallel. So the blue ones are parallel and the red ones are parallel to each other. Okay, so there are two special parallelograms that we can draw off of this. So a rhombus is a parallelogram where all the sides are congruent. So not only are they parallel, they're also the same length. Okay, and a rectangle is a special parallelogram where all of the angles are 90 degrees. Now, if you combine those two together, you get an even more special parallelogram where opposite sides are congruent. All of the sides are the same length, and we have 90 degrees in all the angles, okay? And that's called a square, okay? So remember, a square is a parallelogram, okay? A square is a rhombus because it meets all the needs of a rhombus, and a square is also a rectangle because it meets all the needs of a rectangle, okay? All right, underline the correct word to complete each sentence. All parallelograms are quadrilaterals. Parallelogram just means it has four sides and opposite sides are congruent. It doesn't say anything about angles, so it can't be rectangles. All parallelograms have opposite sides parallel. Okay, opposite sides are not going to be perpendicular ever. Okay, some parallelograms are rectangles. So a parallelogram is never going to be a trapezoid. A trapezoid is a special quadrilateral, remember, where it has only one set of parallel lines. All right, so today we're starting on some area here. So we have a definition. Area is the number of square units needed to cover a given surface. And our main idea is you can find the area of a parallelogram or triangle when you know its length of base and height. Okay, so base and height are going to be important for us. All right, so here we just have some review of how you could do area problems without knowing any formulas. So for instance, this first rectangle here, we could just count up all the little unit squares that are inside it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this has an area of 18 square units. We could also do the same thing with a parallelogram, and it'd be a little bit harder if the squares didn't work out evenly. So there's 5 perfect squares, 10 or 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then there's some halves here that we can put together. Okay, so this would be 16 when I put those two halves together, 17 when I put those two halves together, and then 18 when I put these two halves together. And notice that this parallelogram has the same area as that rectangle. And the reason is a rectangle is a parallelogram, so the formula for a parallelogram works on a rectangle. And this guy would be base times height, so that's base. That's our height, and there's our base, so that would be 3 by 6 for 18, and this one has a height of 3 and a base of 6, so 3 by 6 for 18 again. Okay. All right, so then we could also do a triangle. So this triangle has an area of 3 whole ones plus 1, 2, 3 halves of ones. So this would be 4.5 total. Okay. All right, so remember for a triangle, it's half of a rectangle or half of a parallelogram if you want to think of it that way. So we could find the area of the whole thing, which would be 3 by 3, but we only want half of it. So then we have to erase out this part. So divide it by 2 to get the half we want. So 3 times 3 for 9. 9 divided by 2 is 4.5. Okay. That concludes our first page. Let's flip it over and check the second page. We actually have the formulas here for the area of rectangles and parallelograms. So the area of a rectangle is base times height. You see length times width also. That's perfectly fine with me, but they're just trying to be consistent because remember, a rectangle is a special parallelogram. So the base and height are easy to find since the right angle in a rectangle tells us where to look for the base and height. All right, so the area of a parallelogram is also base times height. And that's because we get the height through the middle. We saw that when we were counting squares last time. So our height is through the middle here, and then our base is the bottom. So if we flip back and take a look again, another way to think about this, in this parallelogram right here in the middle for number 5, we could cut this green piece off, move it to the other side. So we got rid of that green piece, so let's mark it out here. And notice we have the same rectangle that we had in number 4. Okay, so we can take any parallelogram and make it into a rectangle by just cutting off the edge. Okay. All right, explain how finding the area of a parallelogram and finding the area of a rectangle are alike. And this should be something like this. For each figure, parallelogram or rectangle, okay, you find the product, means multiply, right, of the base and its corresponding height. That's why it has the same formula. Base times height. Okay, on problem 1, we have finding the area of a parallelogram. And it says, I got it. What is the area of a parallelogram that has base 12 meters and height 9 meters? So first off, we have to label the parallelogram at the right. So a base is always one of the sides of the parallelogram. It doesn't matter which side. In this case, we have to use the bottom because it corresponds with the height that's drawn through the middle. So we're going to put 12 here. Okay, and then the height is always from the base up to the other base, the opposite base, formed by a right angle. So it's not going to be one of the sides. It's usually going to go through the middle, or they might draw it on the outside somewhere. So in this case, our base would be, our height would be 9. Okay. All right, so find the area. We're just going to substitute 12 for the base and 9 for the height, and then multiply them together, and we're going to get 108. So the area of this parallelogram would be 108 meters squared. All right. Problem number 2, find the missing dimension. Okay, so in this one, we know the area, I think. So a parallelogram has sides 15 and 18. The height of the corresponding, to the 15 centimeter base is 9. And we need to find what is the height corresponding to the 18 centimeter base. Okay. All right, so we're going to find the area and then use that to find the missing side here. All right, so we know that 18, a parallelogram has sides 15 and 18. So this is 18 here, and this would be 15 right here. Okay, and then it says the height corresponding to the 15 centimeter bottom is 9. So this is a 15 centimeter bottom. Its height is 9. I had to draw it outside the parallelogram this time. Okay. All right. So our job is to then find what is the height corresponds to the 18 centimeter ones. That's the question mark. So first off, let's find the area. We do know a base and height that correspond to each other. In this case, the 15 and 9 go together. So the 15 base goes with the 9 height. And 15 times 9 will give us an area of 135. So what is the height that corresponds with this? So we're not done yet. So the area of the parallelogram is 135. Okay, and if we flip to the next page, we have the rest of the questions to walk us through this. So since we know an area is 135, we also know that the other base was 18. And we want to find the height that goes with it. So we'll go back and look at the picture again. So down here we have this 18 base, and we want to find its corresponding height that goes this way. That's the question mark. Now we already know the answer to the area of the 18 times the height. So we plug in the area of 135, height of 18, and then we divide both sides by 18, and we find out that that other height should have been, let's see, 135 divided by 18 makes 7.5. So you're going to use your calculator to help you with that. All right, so the height corresponds to the 18 centimeter base is 7.5 centimeters. Okay. All right, take 10-3, area of a triangle. So the area of a triangle is half the product of the base and the corresponding height. So 1/2 base times height. Okay? Explain how finding the area of a triangle is different than finding the area of a rectangle. So what's different? Well, it has the same formula except for that 1/2 there. So for a triangle, okay, find half of the product of the base and the height. Okay. For area of a rectangle, we just find the product of the base and height, but the difference would be this find the half part. Okay. All right, problem number 3, what is the area of a triangle? So first we have to circle the right formula, and of course it's going to be the 1/2 base and height. And then convert the lengths of the base and the hypotenuse to inches, because right now we have 5 inches for the height. We have this side over here is 1 foot, but we need to make that be inches also, so they can all be inches. So that's 12 inches. And then we had that hypotenuse of this right triangle is 1 foot 1 inch. So that's the same as 13 inches, 12 plus 1. So our bases are going to be 1 foot is 12 inches, and the hypotenuse 1 foot 1 inch is the same as 13 inches. Now we have to find the area of the triangle. So the area is going to be 1/2 base times height. And our base and height, let's see. Well, we have to find a side and of a triangle that we can find a right angle touching, so that one would work. And then that means the height is actually the other side of our triangle. Now that's not always the case. Sometimes the height is through the middle of the triangle and sometimes it's outside of the triangle. But in this case we can use those. So our base of 12 has a height of 5, or we could say the base of 5 has the height of 12. And if we work that out, half of 12 is 6, and 6 times 5 will give us an area of 30 inches squared. Okay, let's flip it over, take a look at the last page here. Okay, problem number 4 on the top of page 4, we have finding the area of an irregular figure. So irregular figure just means it's no basic shape. It's not a rectangle or a square or a triangle or a parallelogram. It's some extra thing. And whenever we have these, we just break them into the shapes that we know. So in this case, we can break our irregular figure into a square and a triangle. Okay. All right, so here's our problem. Suppose the base lengths of the square and the triangle and the figure are doubled to 12 inches, but we're going to leave the heights the same. How is the area of the figure affected? All right, so first off, we need to find the area of the original figure. So the original figure consists of a square, which is just a rectangle. So that's a base times height formula. So they didn't write it in here, but that's base times height, which is 6 times 6 for 36. And then it's combined with a triangle that has a base of 6. 6 is still right here, and a height of 8. So that's where the 6 times 8 times 1/2 comes from. So if you combine that, you get 24, and then you add them together, and this area is 60 inches squared. Okay, and now we're saying, okay, well, what if we double the bases? All right, so we're going to kind of draw over top of this and show what's going on. So now instead of being 6 across here, we're going to make it be 12 across. Still going to have the same height. So now instead of being a square, it's a rectangle. And the same with the triangle. We're going to increase this to have a bigger base. So now it's going to be this triangle. Okay. All right, so we need the base of the triangle be larger. So the height stayed the same. So let's see how that works. They started off with a formula. They have 2 times 6 times 6, and that's because the bottom now is 12, twice as long as it used to be, times 6 for our rectangle. So that's 6 tall, and then this 12 is 2 times 6. Okay, and the triangle, same thing for the thing. It's 2 times 6 for the base. Its height is still 8, and then we have the half there. So that's 2 times 36 and 2 times 24. Okay, we already knew what those worked out to. And here we're going to get 2 times 36 plus 24, which is 2 times 60, and that will double our area to 120. Okay, Now they did it in a weird way to show you that you could calculate the original area and then just double it, because we're only doubling one of the dimensions. So how is the area affected? The area is also doubled. If you only double one dimension, the area will only be doubled also. If you double both dimensions, something else happens that we'll learn about as we go further on. Okay? All right, so our lesson check. As always, pause the video, come back, check it over once you're done. Okay? All right, so parallelogram ABCD is divided into two triangles along the diagonal AC. Okay, so here's our diagonal AC for our parallelogram. If you know the area of the parallelogram, how do you find the area of triangle ABC? Well, if you knew the area of the parallelogram, triangle ABC should be 1/2 of that. That just makes sense because that diagonal breaks our parallelogram into two perfectly congruent triangles. So they're both the same, okay? All right, so write true or false here. Since AC is the diagonal of parallelogram ABCD, triangle ABC is congruent to triangle CDA. This is true, okay? We've proved this before using, let's see, we have the side that's the same in the middle, okay? And then we had these angles are the same, and these angles are the same. So we proved it with side angle before, okay? All right, the area of triangle ABC is greater than the area of triangle CDA. Well, that's going to be false. They should have the same area. They're congruent shapes, okay? The area of triangle ABC is half the area of the rectangle. That's true because that's how we formed it. We broke the rectangle, or the parallelogram in half, not a rectangle. All right, so if you know the area of the parallelogram, how do you find the area of the triangle? You divide the area of the parallelogram in half. Okay. All right, so this completes our lesson. Check off the vocabulary words that you understand. Hopefully you get the idea of the difference between base and heights, okay, and how to find them. Remember to look for the right angle. And you should be pretty good at finding area of parallelograms and triangles. This is not new material. We might do some trickier questions than what you learned in Math 8 or Math 7, but still the same material. All right, I'll see you in class next time.